In 1899, a marvel of modern engineering was constructed in Stuyvesant Falls, New York. The Stuyvesant Falls hydroelectric plant. Nicknamed the little plant that could, because it operated during the big Northeast blackout of 1965, the hydro plant has seen rough times, was closed and nearly destroyed in the 1990s, but now it is back. This is its story.
Hydro is definitely a resource in this area. When you look back at the old maps from the 1800s, you see all of these mill towns. It was flourishing and running on hydro.
Well, hydroelectric power it really captures the hydrologic cycle. And the hydrologic cycle is as rain falls from the sky and goes into the rivers, flows out to the ocean, evaporates, goes back up into the clouds, and then recycles itself back down into the rivers.
Would you say that this is a form of solar energy?
Absolutely, because the evaporation of the water from the oceans and the lakes occurs because of solar energy causing the evaporation. Hydroelectric generation, the basic mechanics of it have not changed since the mid-19th century.
The rainwater that has flowed down from the mountains is collected at a dam. At Stuyvesant Falls, a wooden dam was built in 1827. In 1899, a new dam was built. In this photo, you can see them building the concrete and Portland cement dam slightly below the wooden one. It's still doing fine today.
We're here in view of the upper falls of Stuyvesant Falls. And there's a dam running across the top of it, behind which is kind of a reservoir, you might say. It's called an impoundment. That's the start of 90 feet of water power that feeds the turbines and generators down at the power plant. We see the water going over the falls, but actually the water that's generating the power is going to go down two huge tubes called Penstocks. They're 7 feet in diameter. They're underground. They go to the side of the falls there, underground, down along those trees, down past the lower falls, down to the power plant.
Looking up the hill, we're looking at the lower section of the Penstock. The Penstock has started at the dam about 3,000 feet away.
The water, which has been flowing downhill through the large pipes, or penstocks, enters the plant through these blue penstocks in this diagram. Then the force of the water turns a turbine, which is a rotating device.
The water spins a blade like a ship's propeller. That spins a shaft. That's mechanical energy now. That spinning shaft is connected to a generator, and the generator is comprised of electromagnets and coils of wire. And the movement of those electromagnets across the wire causes an electromagnetic force to be generated, which is called voltage, electric energy. So we've converted mechanical energy into electric energy through the generator. And once that energy is converted to electric energy, it's in wires, and then they go out and they are connected to the electric grid. After the water spins the blade, it comes back out underneath the power plant through these archways. You can see the tops of the archways here. Hydroelectric plants don't add anything to the water, nor do they add anything to the air. We don't have any emissions in hydroelectric plants. We don't burn anything. We have no smokestacks. Small hydro is generally run of river. We use the water as it comes down the river. We have to do a variety of studies. We study fish, we study the flora and fauna of the area. We provide very small screens, very small opening of screens, very low velocity, and essentially keep the fish, as well as other critters, American eel is a good example, out of the flow that goes through the turbine. And so we don't have very dramatic environmental effects. The large dams can have fairly substantial environmental effects. The plant was conceived of in about 1897 by some industrialists, and the primary purpose was not to build a hydroelectric plant. They built the first electric railway in the United States. This was a third rail electric railway that ran between Albany and Hudson, New York. And in developing that railway, they needed a source of electricity, and they decided that the best way of doing that was to build a hydroelectric plant here in Stuyvesant Falls, which is about midway between Hudson and Albany. They built the plant in 1899, and they designed it with a variety of turbines to supply both power for the electric railway, which was direct current, as well as providing alternating current to supply some of the local communities. Because they recognized that the water in the Kinderhook would not be reliable year-round, at the same time they built a coal-fired boiler system as part of this plant. So they had both hydropower here as well as coal-fired power. And that produced enough electricity to run the Albany-Hudson Electric Railway.
The trip from Hudson to Albany was about 1 hour and 15 minutes. The railway also took passengers to the electric park at Kinderhook Lake. Admission was just the cost of the train fare. Such electric parks were being built by the power-producing companies all over the country to showcase and celebrate electricity, their wonderful and seemingly inexhaustible product. Just 20 years earlier, Thomas Edison had invented the incandescent light bulb. The train and park continued through World War I. But then, just before Christmas in 1929, this vital public commuter line, which was powered by renewable energy, ran for the last time.
The late 1920s, the railway system in general and the interurban railway system was undergoing a change, and the trolley system, this was essentially electric trolley, was being overtaken by automobiles. And so what happened here is what happened in many places. The electric railway system was discontinued. Buses took over. General Motors supplied buses to many of these communities. The hydro plant continued to operate, however, supplying power to the local communities. In 1942, they reconfigured the plant and put one new large turbine in, which supplied just alternating current, and started generating a little bit more power here at Stuyvesant Falls. They needed more power for the war effort during World War II.
Bye, 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 baby. When I come back to live the life of me.
But after World War II,
What a dreamy ride.
such energy conservation efforts were abandoned, and energy consumption was promoted as part of the American dream, part of what had been won.
Up in the kitchen, baking a cake.
People were sold more and more electric products. Electricity was abundant.
No need for the bride to feel tragic. The rest is push-button magic. So whether you bake or broil or stew, the Frigidaire kitchen does it all for you. Don't have to be chained to the stove all day. Just set the timer and you're on your way. Tick-tock, tick-tock, I'm free to have fun around the clock.
To supply this ever-growing need for electricity, big oil, coal, and gas-burning plants were built, and the little plants were neglected.
Tomorrow, our dreams will come true.
But in less than 25 years, we found ourselves in trouble. Each year, we used 5% more, doubling our demand every 12 to 14 years. Oil companies during this period were encouraged to get oil and gas from other countries. By 1970, we imported 1/3 of our oil and gas, relying on others to meet new needs. Then in 1973, the big Middle East producers cut off oil shipments to major consuming countries. When the embargo was lifted, the price of foreign oil had jumped from $3 to $12 a barrel, 4 times higher than before.
Well, just looking at my bills, I'm getting upset. Paying more for electricity every month, and the gasoline is going up, and I'm used to being able to go when I want to, but suddenly I think I'm going to have to start curbing my habits.
But the electric industry did not want people to curb their habits, nor did they see the value in little plants that could. The solution to the energy crisis was clear:
to develop our oil, coal, and gas. Much of this country, particularly in the West, was once a sea. And beneath its surface lie rich pools of oil and beds of coal, enough, some say, to answer our needs for centuries.
And so the push for big power plants, including nuclear ones, continued. And although the town of Stuyvesant took great pride in its plant, in 1994 it was closed because it couldn't make enough profit for its owners.
The utility which owned it at that time, Niagara Mohawk, decided that it was no longer feasible to continue to operate the old hydro station, and they discontinued operation in 1994.
We had heard rumors that they weren't operating, that they were doing repairs and so on and so forth. It actually became more evident to us in the late 90s that the production wasn't occurring.
Why would Niagara Mohawk want to mothball a hydro plant? I mean, we think right now energy, hydro, the gold and diamonds of the future.
It's because they allowed things to get in disrepair. And the cost, according to them, to rehabilitate everything was beyond a reasonable cost.
And it was a bit of a shock because Niagara Mohawk was paying a nice piece of money in school taxes, town taxes, and county taxes. And they were just going to let it go.
Paul Nolan contacted me one day, and he is an attorney that works on a lot of hydro projects. And he said to me, "Did you know that Niagara Mohawk had applied to the Federal Energy and Regulatory Commission for rescission of their operating permit for the hydro facility?" And I said, "No." And he said, "Do you know what this means?" And I said, "I don't have a clue." He said, "Well, if they're successful in getting the rescission of their operating license, it'll be many, many, many years before anybody could get a permit to operate that facility again."
Well, the local community felt strongly that the plant should continue to operate for a variety of reasons.
Paul Nolan said, "Then let's file for the permit."
And a regulatory battle ensued at the Federal Energy Regulatory Commission in Washington, D.C. Between the local community, the town of Stuyvesant, and Niagara Mohawk Power Corporation. Ultimately, the Niagara Mohawk Power Corporation prevailed, and the federal government allowed Niagara Mohawk to surrender their license to generate here, essentially mothballing the plant. The town, however, didn't give up. They continued to pursue development of the project in some fashion, either themselves or with a partner.
Could the town of Stuyvesant have decided to become a municipal power company? Absolutely, they could have. Now, one of the town councilmen, Matt Asbjornson, thought that they should.
Both Matt Asbjornson and Todd Grenche, who's interviewed here, worked tirelessly to revitalize the plant. But becoming a utility company was just too expensive for a small town.
Through Paul Nolan, we were introduced to Albany Engineering, James Besha.
We specialize in hydroelectric projects. We have for probably 25 years now. We design, we own, we operate, develop, we maintain, and we construct projects. We own and operate the oldest continuously operating hydro project in the world at Peconicville, New York, built in 1897. In the last 15 and 20 years, we focused pretty much around Albany, New York. There's plenty of water resources for us here. He
began to look and assess the property. They came in and they did some studies on the Penstocks. They made a determination that the Penstocks were not in the severe disrepair that had been claimed, that they could be repaired, and we began the process of formulating an agreement.
And in 2003, thereabouts, through the efforts of Senator Schumer, there was a congressional reinstatement of the license. The license that had been surrendered was brought back to life by Congress, signed into law by President Bush, and the town of Stuyvesant became the new licensee, along with their new partner, Albany Engineering Corporation, to redevelop the project.
We used to laugh that it took an act of Congress, that Congressman Sweeney and Senator Schumer were very active, and the town of Stuyvesant as a municipality was given the operating license. But they held on to the property.
So now the town of Stuyvesant had a provisional operating license. But they didn't own the plant. Who did?
NIMO sold the property here to some outfit called Orion. Orion sold the property here to an outfit called Reliant Energy that was from Texas. Then Reliant sells it to, and here's where I'm even more confused. There's an entity called Brookfield. There's an entity called Brascan, which is a power generating company in Canada. And then there's something else called Erie Boulevard. Was this all part of leveraging derivatives and real estate deals that led up to the crash of 2008? I don't know. Who are these people? It's not easily accessible to the average person or the average electric bill payer what's going on. So something that when I was a little kid we thought of electricity as a public utility is something else altogether.
After that, a multi-year effort was underway to acquire the facility.
I was alerted to a public hearing. They were talking about an eminent domain taking of the property. An eminent domain is when a property owner is going to be forced to sell their property. It's not just taken for nothing. Forced to sell their property at some determination of fair market value to be sold for a purpose that's considered in the public good. And in this case, it was to generate hydroelectric power. And it took quite a while to get a decision, but ultimately the decision was that since Reliant, whoever they were, Brookfield, Brascan, Erie Boulevard, had never actually put the plant into production. And since Albany Engineering had a good track record of rehabilitating these old hydro plants and putting them into production, that Albany Engineering, in cooperation with the town of Stuyvesant, was able to buy the property.
So Albany Engineering buys the plant from Erie Boulevard, and the real work begins.
This plant will generate about 7,000 kilowatts on a peak day. A kilowatt is about enough to supply the average home. Figuratively speaking, this would generate enough power to supply about 7,000 homes when it's operating at peak.
We have 2,000 homes in our town. So this is very definitely a valuable piece of infrastructure. Even though the power that's generated will kind of be invisible to us because it goes out to the grid. However, a certain amount of money comes back to the town.
The plant, which is a private power plant, pays real estate taxes. Not just on the building, but it pays real estate taxes on the equipment, which is very unusual.
In addition to real estate taxes, the town receives a licensing fee from Albany Engineering. And of course it benefits by having a working historical landmark in its community.
It's one of the earliest hydroelectric plants in the world.
It's definitely a key to local, sustainable energy in our community.
There's estimated to be about another 2,000 or 3,000 megawatts of small hydroelectric power that could be developed in New York State alone. The turbines in this plant were built in 1931. The Penstock date to 1899. Powerhouse was built in 1899. But it will all be controlled with computers.
Brakes are going off. Brakes are off. No rotation. About 5%. Yes, they did. Still no rotation. No movement. Movement.